Hey folks, problem number 2 on that worksheet. Cholesterol reducing medication. Does the medication have any effect? Any effect? Is the proportion of cholesterol reduction different in the medication group than in the placebo group? Different. Any effect? Okay, so there's two groups, and we have a medication group and a placebo group. So let's see, the null. There's two groups, and we're talking proportions, and they want a hypothesis test. Focus, camera. Camera. Good camera. Okay. So the null is just going to be P1 equal to P2. And then our alternative, it's going to look very similar. Less than, greater than, or different. Any effect. We don't know if it's more or less. Is the proportion of cholesterol reduction different? Okay, different. So any effect would be, they're the same, they're different. This is no effect. This is has an effect. No effect, has an effect. Okay. Test stat. Test stat. Okay. So we just got to throw the data in there. Clear stat tests. So hypothesis test, two proportions, go down to two prop z test, enter. Okay, 399, enter. 3500, enter. 375, enter. 3400, enter. Does not equal symbol. Okay, choose the does not equal symbol, go down to calculate, hit enter. Okay, test stat of z equal 0.4876, so 0.488. Why did I go to the third place? No particular reason. I just didn't want to write a bunch of things. If you round, just round correctly, so 0.488. P-val. P-val. Not p-hat 1 or p-hat 2, but the p-val, 0.6257, so 0.626. Again, rounding to three places for no particular reason. Okay, alpha, that's my significance level. It says 5%. How does that compare to my 0.05, which is my alpha? That is greater than. If my p-val is greater than my alpha, then I say do not reject HO. So my statistical conclusion is do not reject HO. Some books say fail to reject HO. Sometimes I accidentally say that. Same thing. Do not reject HO. Fail to reject HO. Notice that we accept nothing. We're being very careful with our words. Do not reject HO. Statistical conclusion. And now conclusion in plain English. Okay, so if it's do not reject HO, then I say not enough evidence to suggest. Not enough evidence to suggest that the proportions are different. Not enough evidence to suggest that the proportions in cholesterol reduction not enough evidence to suggest that the proportions in cholesterol reductions from the medication group are different than the placebo group. What if I just write this? Not enough evidence to suggest that the proportions in cholesterol reductions are different between the groups, between the medication and placebo groups. Not enough evidence to suggest that the proportions in cholesterol reductions are different between the medication and placebo groups. That sounds good. So I was just trying to put this into words. So not enough evidence to suggest the proportion of cholesterol reduction in the medication group is different than the proportion of cholesterol reduction in the placebo group. If you just want to be literal. Either one, make sure you have that keyword different. Notice I didn't say same. So if I'm just grading this really quickly, not enough evidence to suggest different. Proportions different. Aha. Okay. Oh, one more thing leading us into the next problem. So the next problem is a confidence interval. So notice how this was a two-tailed test, right? Two-tailed test. So remember we studied previously that a two-tailed test is the same thing logically as a confidence interval. Confidence interval. Okay, so this one was alpha 05. So since this was a two-tailed test 05, it was actually logically equivalent to a confidence interval of 95% confidence. You see how those two numbers have to add to 100%? Now let's take a look at this null hypothesis. P1 equals P2. Let's write that down right here. P1 equals P2. Another way of writing that, let me use another piece of paper. Wasting paper, that's what I do. Okay. Paper. So the null hypothesis was that P1 equals P2. So what if I take that idea P1 equals P2 and just rearrange it algebraically? What if I subtract P2 from both sides? Then that would be P1 minus P2 is equal to 0. So the null hypothesis, you could write it like that, or you could write it like that. Most of the time we write it like that, but it's helpful to sometimes think of the idea like this. Let's see why they're the same. Okay, P1 and P2 are equal. P1 and P2 are the same. Okay. The difference between P1 and P2 is nothing. There is no difference between P1 and P2. Oh, you mean they're the same? Yeah, they're the same. The difference between them is nothing. There is no difference between them. Oh, okay. Algebraically, I see it, and logically, it makes sense. So this is going to lead us into the next problem, question 3, where we're making a confidence interval. So once we make our confidence interval, what number do you think we're going to be looking for in that interval? Okay.